one more of these radian things, radian equations that have fractions. This is just going to be a good exercise on how to deal with fractions. So we've just done this before in class several times, but we're going to have to again factor out the 5/9 out of that equation. This will be 5/9. So I have to divide 2 pi over 7 divided by 5/9. So that would be my expression where I take the numerator, divide by the denominator. So this would be 2 pi over 7 divided by 5/9, which gives me 2 pi over 7 times 9 over 5, which looks like to me to be 18 pi over 35. You can always check your work just to make sure you did this properly by multiplying this times this and reducing the fraction. It'll break the fraction down to 2 pi over 7. So that looks like we did that right. So this graph is going to have to begin by shifting it to the left. 18 pi over 70. A negative 18 pi over 35. I was thinking ahead. So that's negative 18 pi over 35. And we know for a secant graph, I've asked you to draw a cosine graph as a template or a guide to draw your secant graph. So this would be one full period from here to here. So I'm marking these as my periods. I've also asked you to do one more extra increment to the right and to the left, and we will do that when we get done. But for right now, I've got 18 pi over 35. Now we have to still calculate my period. My period is equal to 2 pi over 5/9. So that would be equal to 2 pi over 1 times 9 over 5, which gives me 18 pi over 5 as my period. So I'm going to take this, everything we've done here, well before, let me get my increment. My increment for each of the 4 increments will be 18 pi over 5, which is my period, and dividing that by 4, which will give me 18 pi over 5 divided by 4 gives me 18 pi over 5 multiplied by 1/4. That will give me 18 pi over 20. Now, probably the best thing for us to do is every time we can, let's reduce one of these fractions. So 18 pi over 20 reduces down to 9 pi over 10. So I'm going to just take that picture and move it to the next page and just reiterating everything we've done. So this is a graph that is shifted to the left 18 pi over 35. I'm going to draw my cosine curve because I know I have to do that. I'm going to do it for one full period with 8 increments. 1, 2, 3, 4 with 4 increments, I'm sorry. So that's my shift left of 18 pi over 35. That's a left shift, so that's negative 18 pi over 35. We have a period that we calculated to be 18 pi over 5 was my period, and my increment was dividing the period by 4, which we said was going to be equal to 18 pi over 20, and we reduced that down to 9 pi over 10. So we have 3 different denominators. We have a 35, and we have a 10, and we also have a 5. Just kind of putting those all together to find the lowest common denominator for all 3 of those. If we break these into prime factors, the first prime factor that divides into 35 is going to be a 5. That's multiplied by 7. 10 broken down into 2 times 5, and 5 breaks down to 2. Just plain old 5. Okay? So we scan this thing, we look at all the different prime factors that we've used. We've used 5, and we used 2, and we've used 7. And we locate, where did I use 5 the most in any one breakdown? Well, I used it once here, and once here. So the most I used it in any one breakdown is just plain old one time. Where did I use 2 the most? I didn't use it all here, but I used it once here and none here. So the most I used in any one breakdown is going to be one time. And 7, of course, is only used one time in any one breakdown. So if I multiply those together, I get 5 times 2 is 10 times 7 is 70. So for all three denominators, 70 is going to be my best option. So I can make everything balance and everything work out fine. So I'm going to again draw this curve one more time, and let's apply each of the increments to that. So this will be one full period. We said each increment was equal to 9 pi over 10, but I want a denominator of 70. So I'm going to take that equal to 70. So multiplying this by 7, this will be 63 pi over 70 to be my increment. Making this 70 as well, we got to make that 70 as well. I know that 5 times 14 is equal to 70. So I'll multiply both top and bottom by 14, and 18 times 14, we're going to see be equal to 252. So this will be equal to 252 pi over 70. I know some of you might look at that and say, why do I need to do that? If I got the increment and I got where it starts, that's all I need to do. Well, let's look how that is going to play into a positive thing for us. I'm going to convert that also to denominator 70, making that a minus 36 pi over 70. So I'm going to begin this as negative 36 pi over 70. I'm going to add 63 pi over 70 to that, and that will give me my next value that I'm looking for. So if I take a negative 36 and add to that 63 pi, that will give me a total of 27 pi over 70. So I added the increment of 63 pi over 70 to a negative 36, and that will give me 27. I'm going to add another 63 to that, and that would give me a value of 90. 90 pi over 70. And adding another one of those to that, 90 plus 63 again takes me to 153 pi over 70, and one more of those increments plus 63 to that, I get 216 pi over 70. Now keep in mind that's one full period. Now if I want to see how far it is from here to here, that would be 216 plus 36, because I'm going in the other direction, a negative direction from 0. So if I add those together, I get a value of 252 pi over 70, which should be the period which correlates to this. So that's kind of like a double check of, did we do everything right for one full period? And then we ask you to go left one more time for one more increment. So that would be a negative 36 minus 63 gives me a value of a negative 99 pi over 70, and another increment beyond 216 pi, so I can bring this down to the x-axis, and 216 plus 63 takes me to the value of 279 pi over 70, and I've got all the increments plus the extra increments to get so I don't leave this curve stopped at its amplitude. So that's why we do that. So we go back to, what did we start start with? We started with y is equal to secant 5/9 x plus 2 pi over 7 plus 1. So that's what we started with. So that means if we looked at the amplitude of this, I had just a 1 here, so there's only amplitude of 1, so this goes up to a height of 1, 0, and now at a negative 1 along the y-axis. And then it says we're going to shift up 1, so that 1 now becomes a 2, that 0 becomes a 1, and a negative 1 now becomes my 0. Now to actually draw the secant curve, after I've done all that, we've got the vertical asymptotes for the secant in red, and it's going to bump up against the curve at its maximum point. And again, we've got our u's right there, and the secant curve will actually be in red, using the cosine curve as my template or my guide to draw that secant curve. Hopefully that's helpful to you. There's another radian type graph to do, and I chose secant because you had to draw cosine and secant together. So I think a lot of us can do the sine and the cosecant curve very readily, and I think I have another